So, hey guys, welcome to my YouTube channel. Today we are going to solve a DSA problem. This problem is called longest subarray with sum k. This problem is from Striver's A to Z sheet and is not available on lead code. I mean the exact problem is not available on lead code. We have a similar problem. So what this problem states is we are given an array and we are also given a k which is 15. So we have to find a subarray such that it's the longest subarray and its sum is 15. So our array has 10 and 5 which is 15 with the length 2, and also our array has 5 plus 2 plus 7 plus 1 which is also 15 but with length 4. So our output is going to be 4 as our longest subarray with sum 15 is 4 length. So this is the basic approach. Today I am going to solve for considering that our array contains only positive numbers. If our array contains negative numbers, we have to use a hash map approach. So let's get started. So hey guys, let's do a dry run of our problem first. So for this problem, you have to start with a brute approach first in an interview. So the brute approach for the longest subarray with sum k would be to generate all the possibilities of the array by using two for loops. I'm not going in detail for that approach, but it's a very easy approach. So it will take big of n square time complexity and big of 1 space complexity. Also, for better approach, we are going to use a prism hash map. And for the optimal approach, we are going to use two pointer or sliding window. So these are the three approaches for our problem. So the optimal approach, which is the two pointer approach or the sliding window approach, only works when our array has all positives. If not, then this approach is not a valid approach if our array contains negatives. This is because sliding window only works when the array is predictable or monotonically increasing. Else, sliding window approach will not be applicable if the array contains negative elements. So this approach, first you have to check the question. If the question states that there are only positives, this approach is the best approach. And this, the better approach, for which is the prism hash map approach. This approach works everywhere and it takes time complexity of big O of n and space complexity of big O of n, as we have used a hash map. So this approach would be the optimal approach if our array contains negatives. So we are going to start with our optimal approach first because it's the easiest to grasp and it will be easy for you to learn as well. So let's get started. So the optimal approach uses two pointer or a sliding window. So let's start. So we use two pointers, which is a right pointer and a left pointer, and we maintain sum, the sum of the window we have, which is initially 0, and also the maximum length, max length, which is initially 0. So what we do, so initially our pointer is at index 0. So initially our pointer is at index 0. So initially our sum is 10. So now our target, let's say our target is 15. K is equal to 15. So if our target is 15 and our sum is 10, it is less. So we move our right pointer to index 1. Now our sum becomes 15. So if our sum is 15, which is equal to our target, we update our maximum length, which becomes 2. Now we again move forward. So now our sum becomes 17, which is greater than our k. Now a property of sliding window is that we have to shrink it till our sliding window becomes valid. So we shrink our sliding window until our sum is less than our k. So we shrink our sliding window. This is our right pointer, this is our left pointer. So as we shrink our sliding window, our sum becomes 7. So which is less than k. Now we stop. Now we again increase our right pointer as our sum has become less than 15. So again our sum becomes 14. Our max length is still 2. Our sum is still less than k. So we keep increasing the right pointer. So our right pointer comes to index 4 and our sum becomes 15. So as our sum becomes 15, which is equal to our k, we update our maximum length. So our maximum length becomes 4 minus 1 plus 1, which is r minus l plus 1, which is 4. Now we increase our right. So our sum becomes 15 plus 9, 24. So as our sum is 24, we shrink our sliding window's left pointer. So again our sum becomes 19. We again shrink our sliding window. So our sum becomes 18, which is still more. So we again keep shrinking and our sum becomes 10. Now it's less and we move our right. And as our right is out of bounds, we stop here and we return our maximum length, which is 4. So as our left pointer moves from left to right only once, and our right pointer also moves from left to right only once without moving backwards, so our overall time complexity becomes big O of n. This is our time complexity, and our space complexity is still big O of 1 as we have not used any extra space. So this was the optimal approach. Okay, so let's get to the code for our problem. So our code is quite simple. So as I said, we maintain two pointers, which is the left pointer and the right pointer. So left pointer is initially 0 and right pointer is also initially 0. The sum is initially 0 and the maximum length is also initially 0. Now we first add the sum of the right pointer to our sum, and then we keep shrinking the window from the left until our sum is greater than our k. So this is the while loop for that. So and at any point if our window is valid, we check the length. The formula for length is obviously right minus left plus 1, and we calculate the max length. We check if our current length is greater than our maximum length, and if yes, we update the maximum length, and after all that we return our maximum length. So it's a quite easy code. I recommend you to try it yourself, and if you have any doubt, let me know in the comments. So let's meet in the next video, as this is the optimal approach, and this approach is only valid when there are all positives. So if our array contains negatives, this approach will not work. In next video, I will come with the hash map approach, which is valid for all type of numbers, positive, negative, or 0. So till then, bye bye.